For small samples, a microwave oven can heat things pretty uniformly from the inside. So, which cube tends to cool the fastest for its size, with very little heat buildup inside? In other words, which cube has the largest surface area to volume ratio? Conversely, which cube tends to have less surface for its size to cool off, and therefore, heat up more? In other words, which one has the smallest surface area to volume ratio? For small cheese cubes that are less than 2 centimeters in thickness, the microwave energy is able to penetrate and evenly heat the whole cube. After 8 seconds, the largest cube, with the smallest surface area to volume ratio, visibly started to melt first. A small surface area to volume ratio means slow cooling, which leads to faster heat buildup inside the cube, and ultimately leading to early melting. Actually, if the cubes were small enough, below 0.8 centimeters, the cheese cubes will never get hot enough to melt at all. The large surface area per unit volume ratio enables the smaller cubes to lose heat as fast as it's being generated inside, and therefore, they never get hot. Now, let's look at the first set of cheese cubes shown at the beginning. Which of these do you think will melt first? The 2 centimeter cheese cube visibly started to melt around 6 seconds, and probably the larger one started to heat up as well. But the 1 centimeter cube did not start to melt until 4 seconds later at the 10-second mark. The 3 centimeters cube also started to melt around 10 seconds. Since microwave energy only has a couple of centimeters of penetration depth for most food samples, the larger cheese cubes were heated from the outer layers first, and then heat was conducted inwards. So, the bigger the cube, the longer it takes to melt.